How can electrons fired one by one still paint a clean interference pattern as if they were waves? In the energy filament theory, the double slit does not turn a particle into a wave. It writes two root conditions into the energy C at the same time. And the interference stripes are the C-state projections of those competing conditions. Textbooks often say the electron is both particle and wave, which is catchy, but it can leave you with the wrong mental movie. A tiny ball that somehow smears into mist, then magically recondenses. Instead, start from what a wave really is here, not a blurry object, but a real pattern in the C pulling and direction. The C carries a tightness landscape, the tensional field, and a direction landscape, the texture field. And any boundaries you introduce forces those landscapes to settle into a particular arrangement. A boundary is not passive, a boundary is a constraint. Like carving a canal through a coastline, the water nearby must reorganize to satisfy the canal's shape. Now imagine two narrow slits as two tight shipping lanes cut into that coastline. Each lane has its own boundary constraints. So each lane forces the surrounding sea to form a relatively stable canal-like sea state in its neighborhood. With one slit open, the sea prefers one family of roots. With two slits open, you don't get two independent stories, you get one combined map. Because both constraints are present and the sea must satisfy them together. That's what superposition means in this picture, not to ghost electrons, but two channel solutions written onto the same sea, where the two channel solutions reinforce where the tightness ripples line up and the directional texture stays compatible. The route to closure on the screen becomes easier, like walking on a well-paved road, where they oppose tightness peaks meeting troughs. Texture pulling against texture, the route becomes harder, like trying to walk through loose sand. That difference in ease is what your detector reads as bright and dark fringes, not an electron arguing with itself. But the sea is making some closure locations statistically cheap and others statistically expensive. That's why moving the screen, changing slit width, or adding a boundary plate predictably reshapes the pattern. You are literally redrawing the sea chart, not changing the electron's personality. So the interference pattern is not a mystical painting made by a conscious observer. It is a navigation map made by boundaries. And now the classic follow-up question lands with no drama. If the sea carries a smooth wave-like map, why does the screen still show one dot at a time? Because the dot is not the wave, the dot is the gate. Emission and detection are both threshold processes. A packet forms under a source side formation threshold. Then it completes under a detector side closure threshold. Between those endpoints, the envelope propagates and interferes like any wave pattern in a medium. At the endpoints, transactions are indivisible. That's why you can have both. Waves sculpt the road, thresholds light the match. Try a simple analogy: open to water gates upstream and release little boats one at a time. The river is not two boats at once. But the flow field created by two gates can still create preferred lanes, quiet pockets, and chaotic zones downstream. Each single boat still lands in one place. Yet after many boats you can draw a stable statistical map of where boats tend to go. In the same way, each electron hit is a single closure. But the accumulated dots reveal the sea's high probability routes and low probability routes, your bright bands and dark bands. Next episode, we'll install a what path detector beside the slits and watch the fringes vanish. Then we'll name the exact physical price you paid to learn the path. Tap follow, share it on New Physics, Clear Universe.